Welcome to Study Loop.
Now this is a long, tiring question, so let's hunker down. For part A, we know the equation is tan gamma is equal to gamma. We want to find out, we know that the intensity is I naught sine square beta by 2 by beta by 2 squared, and we want to show that the maximum of this equation occurs when tan gamma is equal to gamma. Notice that beta by 2 is gamma, and hence we can write this as sine square gamma by gamma squared. Now, to find the maxima of this equation, we simply do the derivative with respect to the derivative of intensity with respect to gamma is equal to 0. Now, to do the derivative of this side, we have I naught times. Now, let's take the derivative of the numerator. That will give you 2 sine gamma times the derivative of sine gamma, which is cos gamma by gamma squared. Then for the second term, we take the derivative of the denominator. That is sine. So we leave the numerator as is. And the derivative of 1 by gamma squared is minus 1 by gamma cubed. Now this is equal to 0. Now we can simply cancel I naught because I naught we know is non-zero. Gives us, we can take sine gamma and gamma square out, which gives us sine gamma by gamma square. If you take out 2 cos gamma is equal to there is a 2 here because the derivative of 1 by gamma square is minus 2 by gamma cubed, which gives us, we can pull the 2 out too, which gives us 2 times sine gamma by gamma square times cos gamma minus sine gamma by gamma is equal to 0. Now we know that sine gamma is non-zero because when sine gamma is 0, that corresponds to a minima. When we are looking for maxima, this can't be 0. Hence, we can safely ignore this term and we can write cos gamma is equal to sine gamma by gamma, and rearranging this, we get tan gamma is equal to gamma. Now that we have this, we want to find out the first few solutions. Now obviously gamma is equal to 0 is a solution, tan 0 is equal to 0, and hence gamma is equal to 0 is a solution. But to think of it graphically, we can draw the graphs. Tan gamma is equal to y and gamma is equal to y. So this is gamma axis, this is y axis. So the first graph, which is gamma is equal to y, simply goes like this. Let me draw it a little askew. And tan gamma is equal to y has graphs that look like this. This is the graph of tan theta, if you remember. We know that this is pi by 2, this is pi, this is 3 pi by 2, this is 2 pi, and this is 5 pi by 2, and so on. So we need to find these points which correspond to the solutions. Now, for the first solution, we know it must lie between pi and 3 pi. It must lie within this range. So the first solution lies between pi and 3 pi by 2. We know that pi is 3.14 and pi by 2 would be 4.71. 3 pi by 2 is 4.71. As you can see, this is very close to, this is in between pi and 3 pi by 2. So the gamma value must be in between these numbers. So let's start trying with 4.6. I'll write down the value of gamma and the corresponding value of tan gamma. Now, if gamma is equal to 4.6, we can simply plug into a calculator and see tan gamma is 8.86, which means we are in this area. beyond the point where tan gamma is larger than gamma. So we go lower. We look at 4.5. For 4.5, tan gamma turns out to be 4.64. As you can see, they are much closer, but this is still larger, which means we are still in this region. So we use 4.45. This turns out to be 4.42. Now, as you can see, tan gamma is smaller than gamma, which means we are in this region. So we go in between 4.5 and 4.45, giving us, let's try for 4.49. I'm sorry, for 4.45, it was 3.72. So now that we have this, let's go to 4.49, which is larger. For 4.49, it turns out to be 4.42. Now, this is still smaller, which means we are still in this region. So let's go to 4.495. For 4.495, the tan gamma value turns out to be, tan of 4.495 is 4.53. See now, tan gamma is larger, which means we need to go lower than 4.495. So if we go back and forth, we'll see that for 4.4934, tan of 4.4934 is 4.4932. As you can see, this has an uncertainty of the order of 10 power minus 4. Hence, this is a good enough value. Gamma is equal to 4.4934, which is 4.49 for 3 significant digits, is the first solution. Similarly, using this method, you can see that the next solution is 7.73 radians and the third solution is 10.9 radians. Well, now that you have these, let's go to part C. For part C, we want to find out where the minimas are. Well, obviously, if you remember the graph, the minimas occur. So let me draw it properly again. Yes. The minimas happen when the values are I'm sorry. Yeah, let's forget this. For minimas, we know I is equal to I naught sine square gamma by gamma. And if you remember, we took a derivative of this and we saw that the solution we got was sine gamma by gamma squared times cos gamma minus sine gamma by gamma is equal to 0. So when this part of the equation was 0, it was a maxima. Turns out when this part of the equation is 0, it will be a minima, because when this part is 0, sine gamma is equal to 0. And if sine gamma is equal to 0, you can see I will be equal to 0. Hence, for sine gamma is equal to 0, I is equal to 0, and it will be the minima. Because sine square gamma by gamma square is a positive quantity, and the least value it can take is 0. Hence, it must be a minima. And for this, obviously, the solutions are gamma is equal to pi, 2 pi, 3 pi, and so on, which are obviously, you can see, are 3.14 radians, 6.28 radians, and so on. If you can simply verify that these values are the values of maximas are not exactly in between the minimas. Now for the last part, we are given a is equal to 12 lambda, which means beta is 2 pi by lambda a sine theta, which becomes 2 pi by lambda, a becomes 12 lambda sine theta, and you get beta by 2 equal to 12 sine theta. 12 pi sine theta. We know that I is equal to I naught sine square beta by 2 by beta by 2 squared. So by substituting for beta by 2, we can see that this is I naught times sine of 12 pi sine theta squared by 12 pi sine theta squared. Now, for this to have the first minimum, we know that beta by 2 is equal to pi. In the diffraction pattern, this happens at pi. This is 3 pi by 2 and this is 2 pi. So the first minima is at pi, which means 12 pi sine theta is equal to pi, which gives us sine theta is equal to 1 by 12. Solving this equation by using theta is equal to sine inverse of 1 by 12, we can see that theta is 0.0834 radian or 4.78 degrees. Similarly, for the first maxima after this first minima, beta by 2 equal to 3 pi by 2, and we get sine theta is equal to 1 by 8, and solving this we get theta is equal to 0.125 radians, which is 7.2 degrees. For the second minima, which happens at beta by 2 equal to 2 pi, sine theta is equal to 1 by 6 and theta is equal to 0.167, which is at 9.6 degrees. That is it.